Every year, millions of tons of macadamia nuts make their way from lush orchards to kitchens and factories around the world. Known as one of the most luxurious nuts, macadamias are prized not only for their rich, buttery flavor, but also for the high-quality oil they yield, used in everything from gourmet cooking to skincare. But how exactly are these precious nuts grown, harvested, and transformed into the products we enjoy every day? Today, we'll take you behind the scenes of massive macadamia farming and processing, exploring how they are cultivated, sorted, cracked, roasted, and pressed into golden oil. Stay tuned, because the journey from tree to table is more fascinating than you might imagine. Macadamia trees originally come from Australia, where indigenous people valued their kernels for centuries. In the modern world, large-scale production takes place not only in Australia, but also in Hawaii, South Africa, Kenya, and parts of Latin America. These trees thrive in subtropical climates with rich, well-drained soil. It can take 5 to 7 years for a macadamia tree to begin producing nuts, and full maturity may take over a decade. Farmers invest years of care before they see significant harvests. Each orchard can contain thousands of trees, carefully arranged to allow sunlight, irrigation, and easy access for harvesting machines. Macadamia trees bloom with long, delicate clusters of white or pink blossoms known as racemes. Each raceme can hold up to 300 tiny flowers, but only a few will develop into mature nuts. Bees play a vital role here. Pollination is essential to achieve strong nut yields. Many farmers even maintain beehives directly within orchards, ensuring a healthy pollinator population. After pollination, small green husks begin to form, slowly hardening over the next 6 to 7 months. Every year, the global macadamia industry produces over 250,000 metric tons of in-shell nuts, with production steadily rising to meet booming demand. The harvesting season is one of the most crucial phases in this journey, when years of careful cultivation finally pay off. Unlike many other nuts, macadamias are not forcibly shaken or knocked from their branches. Instead, these prized nuts fall naturally when fully mature, ensuring maximum flavor, nutrient content, and oil concentration. Traditionally, indigenous communities in Australia gathered macadamias by hand. Today, large-scale farming relies on sophisticated machinery designed to sweep, collect, and transport millions of nuts efficiently. In modern orchards, mechanical sweepers move systematically along the tree rows, brushing the fallen nuts into windrows. Behind them, vacuum harvesters or pickup machines suck up the nuts and deposit them into storage bins. For example, in Hawaii, one high-capacity mechanical harvester can gather over 10,000 pounds of in-shell nuts per day. In South Africa, a leading macadamia exporter, large orchards spanning hundreds of hectares employ fleets of harvesters that can collect several tons daily during peak season. However, in smaller orchards, especially in Kenya and Malawi, hand-picking still plays a major role. Laborers carefully gather fallen nuts by hand or with small rakes, ensuring minimal damage. While slower, this method helps preserve quality and provides valuable employment in rural communities. Once collected, time is critical. Freshly fallen nuts still carry a green outer husk and have high moisture content. If left too long, they risk developing mold or fungal contamination, which can ruin entire batches. Therefore, harvested nuts are usually transported to on-site husking sheds or collection depots within 24 to 48 hours. In larger operations like those in Queensland, Australia, trucks ferry thousands of pounds of nuts daily from orchards to central processing facilities. To ensure only mature nuts are collected, harvest crews often make multiple passes through the orchards during the season. Instead of stripping trees all at once, farmers return every 2 to 4 weeks to pick up freshly fallen nuts. This staggered collection helps maximize quality, as macadamias ripen at different times on the same tree. For instance, in Queensland, Australia, some orchards may conduct up to 15 harvest rounds per season, ensuring every nut is collected at peak maturity. In Hawaii, drones and digital mapping are increasingly used to track nut fall patterns, helping farmers optimize harvester routes and predict yields with greater accuracy. Once bins are full, they are loaded onto trucks and weighed. Large farms often have weighbridges to measure the exact tonnage delivered from each orchard block. This helps track productivity and plan logistics. At this stage, the nuts are still encased in their tough husks. A typical truckload can carry 10 to 15 tons of freshly harvested nuts, destined for the first phase of processing, husk removal and drying. Some farms also operate mobile de-husking units directly in the orchard, removing husks on site before sending the nuts to centralized dryers. This reduces transport weight and speeds up processing. Modern macadamia farms emphasize not just productivity but also sustainability. For instance, many orchards mulch husks back into the soil, enriching fertility. Some large processors in Australia and South Africa burn husk waste as biomass fuel to power drying facilities, reducing reliance on fossil fuels. Precision farming technologies, including soil sensors and GPS-guided harvesters, help reduce waste and increase efficiency. To visualize the magnitude, in South Africa alone, the 2024 harvest yielded over 70,000 metric tons in shell, enough to fill more than 3,000 shipping containers. Hawaii's farms collectively produce millions of pounds each season, much of which is exported to the US mainland, Japan, and Europe. Worldwide, the macadamia industry now generates billions of dollars annually, with nearly half of all nuts processed for the premium snack market, and the rest destined for oil pressing and food manufacturing. In summary, harvesting macadamias is a blend of tradition and technology. From the careful hand-picking in African orchards to the high-powered mechanical sweepers of Hawaii and Australia, the goal remains the same: collect millions of tons of these buttery treasures at the peak of their quality and deliver them swiftly to processing plants before they lose their perfection. This massive undertaking, repeated every year across continents, ensures that consumers everywhere can enjoy the taste and health benefits of macadamia nuts, whether roasted whole, dipped in chocolate, or pressed into silky golden oil. At the processing plant, the nuts arrive with their green outer husks still attached. Machines strip away the thick husk, revealing the hard brown shell beneath. Next, the nuts are dried in large industrial dryers. This step reduces moisture content from around 25% to less than 2%. Proper drying is crucial. Too much moisture can cause mold, while overdrying can crack the shells prematurely. This careful balance ensures the nuts remain in perfect condition for the next step, cracking. The macadamia nut is famous for having one of the hardest shells in the world, 5 times harder than a hazelnut shell. Breaking it open without damaging the delicate kernel inside is a true engineering challenge. Factories use specialized steel rollers and precision cracking machines. These devices apply just enough pressure to split the shell but not crush the kernel. After cracking, machines separate shells from kernels using air blowers, vibrating sieves, and gravity-based sorting systems. Once freed from their shells, the kernels are carefully graded. Sorting systems use cameras and laser scanners to check for size, color, and quality. Whole kernels are the most valuable, often sold as premium snacks. Halves and pieces are used for chocolate coatings, baked goods, and nut mixes. Lower-grade kernels may be pressed for oil or used in nut butter production. Trained inspectors also check batches by hand, ensuring no defective nuts pass through. For consumption, many macadamia nuts are roasted to bring out their rich, buttery flavor. Industrial roasting ovens tumble the nuts in hot air or oil until golden brown. Some are salted, honey-coated, or covered in chocolate. Others are left raw, ready for gourmet cooking or further processing into oils. Every step is monitored to preserve freshness, as macadamias are high in natural oils that can spoil if not handled properly. Not all macadamias are destined for snacking. A large portion is processed into macadamia oil, prized for its delicate flavor and health benefits. Kernels are cold-pressed using hydraulic presses which squeeze out golden oil while preserving nutrients. The oil is then filtered to remove impurities. Culinary oil is bottled for cooking and salad dressings. Cosmetic oil is used in skincare, shampoos, and lotions, thanks to its high content of monounsaturated fats and antioxidants. Even the leftover nut cake from pressing is recycled into animal feed or used in baking. Finished products are carefully sealed to lock in freshness. Vacuum-sealed bags, nitrogen-flushed cans, and glass bottles ensure a long shelf life. From there, millions of tons of macadamias travel across the world, appearing in supermarkets, gourmet shops, bakeries, and cosmetic factories. Countries like the United States, Germany, Japan, and China are among the biggest importers, fueling a global demand for this luxurious nut. Modern macadamia farming is not just about yield, it's about sustainability. Farmers adopt drip irrigation systems to save water, use organic compost to enrich soil, and plant cover crops to prevent erosion. Some orchards even generate renewable energy from nutshells, burning them to power dryers and machinery. With growing demand for healthy plant-based foods and oils, macadamia farming is set to expand further, blending tradition with advanced technology. If you're fascinated by how everyday products are grown, processed, and brought to life, don't forget to hit that subscribe button and turn on the notification bell. We bring you incredible behind-the-scenes stories every week. Join us and never miss the next journey from farm to factory to your home. Beneath the glossy skin of this deep purple fruit lies a fascinating story of soil, science, sun, and centuries of tradition. From tiny seeds to vibrant harvests, eggplants, also known as aubergines, are more than just a culinary favorite. They're a testament to modern agriculture and ancient farming wisdom.
カモナスです。カモ eggplant. They are getting bigger and bigger.
Today, we journey across lush fields and advanced greenhouses to discover how millions of eggplants are grown, nurtured, and harvested across the world, ready to be turned into everything. This is amazing eggplant agriculture. Every eggplant starts with a seed, but not just any seed. Carefully selected, scientifically treated, and genetically optimized for productivity, resilience, and flavor. Most commercial growers start with hybrid seeds, chosen for traits like disease resistance and faster maturity. These seeds are often pelletized to make mechanical sowing easier. Seedlings are typically started in nurseries, often indoors or in controlled environments. Here, trays of potting mix or cocoa peat are moistened and seeds are gently pressed in, then covered with thin layers of substrate. Within 5 to 10 days, tiny green shoots emerge. These seedlings are then allowed to grow under carefully monitored conditions, constant temperature around 25 to 30 degrees Celsius. Filtered sunlight, and daily watering through mist or drip systems. Once they reach a height of 10 to 15 centimeters with 3 to 4 true leaves, they're ready to be transplanted. Out in the field, everything begins with soil preparation. Eggplants prefer well-drained, loamy soil with a pH between 6.0 and 6.8. Farmers begin by plowing the field, often with tractor-mounted rotavators, to break up the soil and improve aeration. Next comes bed formation. Raised beds improve drainage and root development. Fertilizers rich in nitrogen, phosphorus, and potassium are applied, often blended with organic compost or vermicompost for better soil structure. Once the beds are ready, drip irrigation lines are installed. These lines conserve water and deliver nutrients directly to the root zone. Then, transplanting begins. Workers or machines gently plant each seedling 18 to 24 inches apart, ensuring enough space for the eggplants to grow wide and tall. To protect the crops from pests and regulate temperature, plastic mulch or shade nets are sometimes used. In cooler climates, eggplants may be grown in greenhouses or tunnels. As the young plants establish roots and grow rapidly, they enter the vegetative stage. Strong stems, broad leaves, and purple-veined foliage begin to form. Eggplants are heavy feeders. Farmers monitor nutrient levels carefully and often apply fertigation. fertilizers dissolved in irrigation water to deliver micronutrients like calcium, magnesium, and boron. During this time, pruning is common. Side shoots and lower branches are trimmed to promote airflow and reduce disease risk. Some farmers stake the plants or use trellising systems to support the weight of future fruits. Eggplants are vulnerable to a range of threats. Aphids, whiteflies, and spider mites suck sap and spread viruses. Fruit borers lay eggs in flowers, larvae burrow into fruits, causing damage. Fungal diseases like powdery mildew or bacterial wilt can devastate entire fields. To combat these, integrated pest management (IPM) is used. Sticky traps attract flying pests. Neem oil and biological sprays minimize chemical use. Where needed, targeted pesticides are applied following safety protocols. Eggplant flowers, usually light violet with yellow centers, bloom around 40 to 60 days after transplanting. Soon after pollination, tiny purple bulbs start forming. Eggplants are typically ready for harvest 70 to 90 days after transplanting, depending on the variety and climate. Farmers must harvest at just the right stage, when the fruit is glossy, firm, and reaches 10 to 15 centimeters in length. Overripe eggplants become dull, spongy, and bitter. Harvesting is done manually, using sharp secateurs or knives. Each fruit is clipped carefully, leaving a short green stem attached. This reduces bruising and extends shelf life. Harvesters move quickly, placing the fruit in soft-lined crates to avoid damage. A single acre of eggplant field can yield 15 to 30 tons of fruit per season. In large-scale farms, harvesting may happen daily or every 2 to 3 days, especially during peak season. The fruit is sorted immediately based on size: small, medium, jumbo. Shape: round, elongated, oval. Color: deep purple, lavender, white, even striped. Eggplants come in many forms. Common commercial types include Black Beauty, large and glossy; Thai eggplant, small and round, often green; Japanese eggplant, slender and long; Graffiti eggplant, purple with white streaks. Once harvested, eggplants are transported to packing centers. The clock is ticking. The sooner they're cooled and packed, the longer they stay fresh. At the center, each eggplant is 1. Washed to remove dirt and residues. 2. Inspected for blemishes or pest damage. 3. Sorted and graded using manual or automated conveyor systems. Eggplants are sensitive to temperature and bruising, so they're cooled to 10 to 12 degrees Celsius, then packed in ventilated cartons or plastic crates. Some are even individually wrapped in foam nets to reduce pressure. In export operations, fruits are labeled with variety, origin, date, and handling instructions. Shelf life can range from 7 to 14 days, depending on storage and temperature control. Eggplants are cultivated worldwide, but some regions dominate the industry. Top producers include China, over 60% of global production; India, second largest, especially in the states of West Bengal, Bihar, and Maharashtra; Egypt, Turkey, and the Philippines, significant contributors. Together, the world produces more than 55 million metric tons of eggplants annually. Beyond sheer volume, regional varieties reflect culinary preferences. Asia, stir-fries, curries, grilled dishes; Middle East, baba ganoush, moussaka; Europe, ratatouille, caponata; Americas, eggplant parmesan, grilled steaks. Demand is rising for organic eggplant, greenhouse-grown varieties, and even baby eggplants for gourmet markets. Modern eggplant farming is embracing agritech and sustainability. Innovations include sensor-based irrigation, adjusting water flow based on soil moisture; drone mapping, detecting plant stress and pest hotspots; biodegradable mulch, reducing plastic waste; hydroponic eggplants, grown in nutrient-rich water without soiling. In greenhouses, farmers can grow eggplants year-round, controlling heat, humidity, and light with precision. Yields are up to 3 times higher compared to open fields. Breeders are also developing climate-resilient and pest-resistant cultivars. Some varieties require fewer pesticides while maintaining yield and flavor. Meanwhile, sustainable packaging, cold chain logistics, and fair labor practices are reshaping how eggplants reach consumers. Once packed and shipped, eggplants travel across cities, continents, and cultures. In supermarkets, chefs, and kitchens, the humble eggplant tramps from a glossy harvest to roasted, grilled, fried, or stuffed delights. It's a symbol of versatility. Eggplants absorb flavor, add texture, and pair beautifully with spices and sauces. Beyond food, eggplant extracts are also explored in cosmetics and pharmaceuticals, thanks to their antioxidants and fiber. For farmers, the eggplant is more than a crop. It's a livelihood. For consumers, it's a delicious tradition. And for the planet, it's a crop that thrives under innovation and care. From seed to soil, from harvest to home, the story of the eggplant is one of resilience, adaptation, and flavor. With every glossy fruit comes months of labor, science, and stewardship. And the next time you slice into an aubergine, roast it golden, or savor it in a dish passed down through generations, remember the journey it took to reach your table. Because behind every eggplant lies a story worth telling. Every morning, millions of people twist open a bottle of cherry juice, drawn in by its deep red hue, its tart sweetness, and the promise of health in every sip. But how many ever stop to wonder, where does this juice actually come from? How does a delicate fruit, soft, seasonal, and easily bruised, survive the journey from orchard to bottle without losing its taste, color, or nutrients? This isn't just fruit in a bottle, it's a marvel of timing, temperature, and technology. A race against the clock, where every hour counts. From mechanical tree shakers that can harvest 7,000 cherries in under a minute, to cold press machines that squeeze out liquid gold without crushing the nutrients, from sterile bottling lines moving at 200 bottles per minute, to sustainability systems that turn leftover cherry pits into renewable fuel. And it all begins with a single cherry. Each cherry tree takes years to mature. Farmers invest 3 to 5 seasons before a single fruit is harvested. And once the blooms appear in April or May, everything depends on timing and weather. Too much rain, and the cherries can split before they ripen. Too much sun, and the fruit loses its tart edge. A single late frost can wipe out an entire year's crop. That's why growers monitor every detail, using sensors to measure soil moisture, flying drones to track canopy growth, and sometimes even setting up wind machines to keep cold air away from vulnerable blossoms. Once the cherries hit peak ripeness, there's no time to waste. Harvesting sour cherries for juice is a race against the clock, and nature doesn't offer second chances. Within just a few days, cherries can go from perfect to spoiled. Timing, coordination, and technology all have to align. Unlike sweet cherries, which are often hand-picked to protect their delicate skin, sour cherries used for juice are harvested using machines. These mechanical tree shakers are marvels of efficiency. They grip the tree trunk, deliver a precise burst of vibration, and within seconds, thousands of cherries drop into fabric-covered catch frames spread beneath the trees. The process is fast, clean, and surprisingly gentle. A single shaker can harvest one tree in under 10 seconds. That speed matters, especially when entire orchards, sometimes hundreds of acres, need to be harvested within a few days. Crews often work long hours, starting before sunrise and finishing after dark, just to stay ahead of the ripening curve. The cherries, once shaken loose, are immediately funneled into large bins filled with chilled water. This isn't just for transport, it's hydrocooling, a critical step to lower the temperature of the fruit and slow down enzymatic decay. Within minutes of hitting the bin, the cherries are already beginning their preservation journey. From there, refrigerated trucks are loaded and dispatched quickly. Most cherry juice operations are designed to get fruit from orchard to factory within 12 to 24 hours. Any longer, and the quality begins to decline. Not just in flavor, but in nutritional value too. Each truckload is tipped into massive stainless steel hoppers, where the cherries begin their transition from raw produce to refined ingredient. The fruit is still chilled from the hydro-cooling process, which helps keep microbial growth to a minimum. But time is still a critical factor. The cherries enter a flume system, a water channel that gently moves them forward while washing away debris. This stage removes dirt, leaves, twigs, and any remaining stems. Jets of clean water spray the fruit at high pressure, ensuring surface contaminants are eliminated. But the real precision begins with sorting. As the cherries move down a conveyor belt, they pass through an optical sorting system. This high-speed equipment uses cameras and sensors to analyze color, shape, and size. Cherries that are too dark, too pale, misshapen, or bruised are automatically diverted out of the line with bursts of air. The goal is consistency. Only ripe, plump, and uniformly colored cherries make it through. Quality in, quality out. After optical sorting, the remaining cherries are inspected manually. Skilled workers stand along the belt, trained to catch what machines might miss, like small signs of mold or fruit that looks perfect on the outside but has internal damage. This combination of machine precision and human judgment ensures that only the highest quality cherries continue to the next phase, pitting. The fruit is now clean, sorted, and ready to reveal what really matters, the juicy, ruby red flesh inside. Cherry pits are hard, fibrous, and completely inedible. They contain small amounts of amygdalin, a naturally occurring compound that in large amounts can be toxic. More importantly, they're a physical hazard. No cherry juice can be extracted until the pits are removed. Modern pitting machines are built for both speed and accuracy. Each cherry is aligned into a small cradle that positions it perfectly. Then, a stainless steel rod punches through the center, pushing the pit out one end and leaving the soft fruit mostly intact. It's a delicate balance. Apply too little pressure, and the pit remains lodged inside. Too much force, and the fruit gets crushed, losing juice prematurely. What remains after pitting is pure cherry flesh, plump, seedless, and ready for pressing. By this point, the fruit has traveled just a few hours from the tree, but has already passed through a gauntlet of sorting, cleaning, and precision cutting. Everything up to now has been about preparing the fruit. What comes next is all about extracting the juice in a way that preserves everything people love about cherries: the color, the flavor, and the nutrients. To deliver a clean, shelf-stable product, the juice must go through filtration. The first step is coarse filtration. The juice passes through a series of mesh screens and gravity-fed separators to remove large particles, bits of skin, leftover pulp, and any stray fibers that slip through during pressing. This clears out the bulk of the debris without affecting the flavor. Next comes centrifugal clarification. Using high-speed centrifuges, the juice is spun at thousands of revolutions per minute. The spinning motion forces denser particles to the outside of the chamber, where they're collected and removed. What remains is a significantly clearer liquid, with a smoother texture and more consistent color. Once the juice has been filtered and pasteurized, it's ready for the final step: bottling. This is where science meets precision, and where everything that's been carefully protected, from the orchard to the press, must now be sealed without compromise. First, the juice is transferred to aseptic storage tanks, kept under tightly controlled temperatures and oxygen-free conditions. Oxygen is the enemy at this point. It can dull the flavor, fade the color, and shorten shelf life. Every aspect of the bottling environment is designed to minimize exposure to air, bacteria, and temperature fluctuations. Bottles, whether glass or food-grade PET plastic, are prepared in parallel. Before filling, they're sanitized using steam, UV light, or filtered water rinses. This ensures that no foreign particles or microbes are introduced during the filling process. The bottling line itself is a marvel of modern automation. Filling machines dispense exact volumes of juice into each bottle, accurate down to a fraction of a milliliter. In some facilities, this process happens at speeds of up to 300 bottles per minute. Immediately after filling, bottles are sealed, either with vacuum caps, heat-sealed foil, or tamper-evident lids, depending on the brand's packaging design. This seal locks in freshness and ensures the juice remains shelf-stable for weeks or even months. Each bottle is then labeled with essential information: ingredients, nutrition facts, origin, best by date, and a traceable batch code. This code allows producers to track every bottle back to its source orchard and processing batch, a critical step for both quality assurance and food safety compliance. But before the juice hits the shelves, there's one more line of defense: quality control. Random samples are pulled from the line for lab testing. Technicians check for sugar content, pH, microbial stability, and color consistency. If anything is outside the strict parameters, the entire batch is flagged and held for investigation. Once cleared, the bottles are packed into crates, shrink-wrapped, and loaded onto pallets. From there, they're either stored in refrigerated warehouses or sent directly to distributors and retailers around the world. By the time you see a bottle of cherry juice on the shelf, it's already traveled through a meticulous, multi-stage process, one designed to preserve not just taste, but trust. Every drop represents the combined efforts of farmers, engineers, food scientists, and operators, all working together to ensure the final product meets the highest possible standard. Cherry juice may seem simple at first glance: a refreshing drink, a daily health ritual, a splash of red in your morning routine. It's a journey of transformation, one that turns something fragile and seasonal into something powerful and lasting. If you enjoyed discovering how cherry juice is made, from farm to factory, make sure to give this video a thumbs up, leave a comment with your favorite part, and subscribe for more behind-the-scenes looks into how the foods you love are created. New episodes every week, so hit the notification bell to never miss a drop. Thanks for watching. We'll see you in the next one. In this episode, we follow tea's full transformation. From the sunlit slopes of tea plantations to the heart of high-tech processing lines, we'll uncover the chemistry, the culture, and the silent mastery behind every sip. The journey begins at dawn, when the world is still quiet and the first light brushes across the slopes. This is the hour of the harvest. Tea is picked at its freshest and most flavorful stage, when the leaves are young and filled with essential oils. For most high-quality teas, only the top 2 leaves and a single bud are taken, tiny, delicate, and full of potential. Harvesters, often with years of experience, move quietly through the rows of tea bushes. They work quickly, but not carelessly. Their hands know how to judge a leaf by touch alone. They pick selectively, leaving behind anything overgrown or damaged. This is not random. It is precision, because every leaf plucked will directly shape the flavor of the final tea. It is labor-intensive and time-consuming. A skilled worker may harvest just 10 to 15 kilograms of fresh leaves in a day. After processing, that becomes only a fraction of finished tea, perhaps 2 or 3 kilograms. Each handful is the product of hundreds, sometimes thousands, of careful picks. For large-scale operations, mechanical harvesters are used to cover more ground. These machines can collect large volumes quickly, but they lack the finesse of human hands. They often cut indiscriminately, gathering stems and older leaves along with the tender buds. As a result, the flavor may be less refined, the aroma less complex. Still, for some types of tea and in certain markets, this trade-off is acceptable. But no matter the method, by hand or machine, harvesting is the tea's first transformation. It's the moment when a living plant becomes a product in motion. From here, the leaves begin their metamorphosis. The next step is withering. It is, quite simply, the process of allowing the freshly picked leaves to rest and lose moisture. But in reality, it is much more than just drying. Withering is the point at which the internal chemistry of the leaf begins to shift. The leaves soften, they begin to droop and lose rigidity. Enzymes within the leaf start to activate, preparing for later stages of oxidation and flavor development. Traditionally, withering is done in open-air shelters or shaded rooms where tea leaves are spread thinly on bamboo mats or mesh racks. The ambient air, assisted by gentle breezes, slowly draws water out of the leaves. This process may take up to 20 hours, depending on temperature, humidity, and the type of tea being produced. During this time, leaves may lose up to 30% of their moisture content. In modern facilities, withering is more controlled. Factories use specialized troughs equipped with fans and ventilators to ensure a consistent flow of air. It's time to roll. Rolling is where tea begins to take shape, literally and chemically. After withering, the softened leaves are moved into machines or onto wooden boards, where they are twisted, pressed, or kneaded into specific forms. This step doesn't just give tea its familiar curls, twists, or tiny pellets. It also plays a critical role in developing flavor. When a leaf is rolled, its cell walls break open. This releases natural enzymes and essential oils that were previously locked inside. These substances come into contact with oxygen, triggering a series of chemical reactions that will shape the tea's color, aroma, and taste. In other words, rolling activates oxidation, but in a controlled and intentional way. Rolling is one of the most tactile parts of tea making. Even with machines, many tea makers use their hands to inspect the leaves during and after the process. They look for even texture, proper shape, and a distinctive fragrance that begins to emerge, a hint of what the tea will become once the leaves are brewed. Drying removes most of the remaining moisture from the tea, reducing it to just 2 to 4%. Without this step, the tea would spoil within days. But more than just preservation, drying defines the tea's final character. The right application of heat stabilizes the flavor profile, deepens the aroma, and adds a final touch to the color of the leaf. There are many methods of drying, depending on tradition, region, and tea type. Too much heat, and the leaves become brittle or develop smoky, off-putting flavors. Too little, and the tea remains damp, vulnerable to mold, loss of aroma, and rapid degradation. As the leaves dry, they begin to curl more tightly, darken slightly, and develop a crisp texture. A faint rustle like footsteps on autumn leaves replaces the earlier softness. This is when tea begins to resemble what we find in our teacups, fragrant, dry, and ready for storage. But even now, the journey isn't over. The dried leaves must still be sorted, graded, and, sometimes, blended before they're packaged and sent across the world. Each of these final stages holds its own complexities, its own decisions, and its own quiet impact on what we eventually taste. Because in the world of tea, even the last steps matter. After drying, tea leaves are sorted and graded to ensure consistency and quality. Though harvested together, the leaves vary in size and shape, factors that affect brewing time, strength, and flavor. Sorting separates whole leaves from broken ones, as well as from fine particles known as fannings and dust. Whole leaves tend to brew slowly and yield a more delicate taste, while smaller particles infuse quickly and more strongly. Modern facilities use vibrating screens and mesh filters to automate this process. Grading goes beyond size. It assesses leaf appearance, aroma, and texture. In some cases, expert tasters perform cuppings to evaluate the liquor's clarity, fragrance, and flavor profile. Grading systems vary by tea type. Black tea uses terms like orange pekoe or be up, while green and oolong teas focus more on origin and harvest season. This stage prepares the tea for its next transformation, whether blending, flavoring, or packaging. Not all teas are packaged just as they are. Many go through a final creative stage, blending and flavoring. Blending combines different batches or types of tea to achieve a consistent flavor, aroma, or color. Especially important for large brands that aim to deliver the same taste year-round. Some blends mix teas from different regions, while others combine leaf grades to balance body and fragrance. Skilled tea blenders rely on both science and instinct, adjusting ratios with precision. Flavoring adds another dimension. Natural ingredients like jasmine flowers, bergamot oil, dried fruit, or herbs are introduced to create distinctive scented teas. Green tea with jasmine, black tea with rose, or chai with spices are all results of this craft. Whether subtle or bold, blending and flavoring shape the identity of many teas. Once complete, the tea is ready to be sealed, shipped, and shared with the world. Once blended and flavored, the tea is ready for packaging, a crucial step that protects its quality and extends its shelf life. Packaging must shield the tea from light, moisture, and air, all of which can degrade flavor and aroma over time. Depending on the product, Tea may be packed as loose leaves, in pyramid sachets, or as fine dust in standard tea bags. For premium loose-leaf teas, vacuum-sealed foil bags or airtight tins are often used to preserve freshness. On automated production lines, machines weigh, fill, and seal thousands of units per hour with impressive precision. Labels provide information about origin, type, grade, and steeping instructions, offering consumers a clear connection to the journey behind each cup. From traditional wrapping in paper to modern, eco-friendly compostable materials, packaging has evolved to meet both commercial and environmental demands. Now the tea is ready to travel across towns, countries, and continents to the moment it meets hot water. From the gentle hills where young leaves are plucked at dawn, to the precise chemistry of oxidation, rolling, drying, and blending, to the final pour of hot water over fragrant leaves. Every cup of tea carries with it an invisible journey, a story of soil, seasons, skill, and centuries of tradition. It's easy to think of tea as simple, but the truth is, tea is a masterpiece of patience, precision, and quiet beauty. And the next time you take a sip, you'll know you're not just tasting flavor, you're tasting effort, culture, and time. If you enjoyed this journey from leaf to cup, don't forget to subscribe to our channel. We bring you deeper into the hidden worlds behind everyday things, from food and drinks to the science, craft, and stories that shape them. Hit that subscribe button, tap the bell icon, and join us as we continue exploring the extraordinary behind the ordinary. Your next cup of knowledge starts here.